The definition of a radical exponent is the square root of anything equals a to the power of 1 over n for any real number a, and n is greater than 1. For example, the square root of 9 can also be written as 9 to the power of 1/2 or 3. The cube root of 356 can also be written as 356 to the 1/3 power. When a equals 0, the square root of a is always 0. When a is greater than 0, the square root of a is positive or negative a to the power of 1 over n. When a is less than 0, the square root of a imaginary, because roots of negative numbers are imaginary. The property of rational exponents states that a to the power of m over n equals to the power of 1 over n to the power of m equals square root of a to the power of m. The product of powers property states that a to the nth power times a to the mth power equals a to the nth plus mth power. The power of a power property states that a to the nth power to the mth power equals a to the nth times mth power. The power of a product property states that ab to the mth power equals a to the mth power times b to the mth power. The negative exponent property states that when a does not equal 0, a to the negative mth power equals 1 over a to the mth power. The zero exponent property states that when a does not equal to 0, a to the 0th power equals 1. The quotient of powers property states that when a does not equal to 0, a equals the nth power over a mth power equals a to the mth minus nth power. The power of a quotient property states that when b does not equal 0, a over b to the mth power equals a to the mth power over b to the mth power. When a and b are real numbers and n is an integer greater than 1, the following properties are true. The product property states that if the degree of the root or n is an integer greater than 1 and a and b are real numbers, then the root with degree n of a b equals the root with degree n of a times the root with degree n of b. The quotient property states that if the degree of the root or n is an integer greater than 1 and a and b are real numbers when b is not equal to 0, then the root with degree n of a over b equals the root with degree n over a over the root with degree n of b. Conjugates are the expressions a root b plus c root d and a root b minus c root d. Multiplying the denominator of a radical expression by its conjugate will result in a rationalized denominator, thus simplifying the expression. The parent function of square root functions is f of x equals the square root of x, which the graph shows. The parent function of cube root functions is f of x equals the cube root of x, which the graph shows. Horizontal translations, the function f of x minus h is used when h is not equal to 0. When h is less than 0, the graph is shifted left. When h is greater than 0, the graph is shifted right. For vertical translations, the function f of x plus k is used when k is not equal to 0. When k is less than 0, the graph is shifted down. When k is greater than 0, the graph is shifted up. Another type of transformation is a reflection. A reflection flips the graph over the line of reflection. Reflections of the x-axis multiply outputs, all y values, by -1. Reflection over the y-axis multiplies inputs or x values by -1. Horizontal stretches and shrinks multiply inputs by the variable a, which stretches or shrinks the graph by a factor of 1 over a. The function of a horizontal stretch or shrink is y equals f of a times x. When a is between 0 and 1, it is a horizontal stretch, which moves it away from the y-axis. If a is greater than 1, it is a horizontal shrink, which moves it towards the y-axis. Vertical stretches and shrinks multiply outputs by the variable a, which stretches or shrinks the graph by a factor of a. If a is greater than 1, then it is a vertical stretch, which moves it away from the x-axis. If a is between 0 and 1, it is a vertical shrink, which moves it towards the x-axis. Radical equations is simple. First, you isolate the radical. Then you get rid of the radical. If it is a square root, square both sides to get rid of the radical. If it is a cube root, cube both sides. If the root has a degree of 78, raise each side to the equation to the 78th power. You get the idea. Finally, using properties that you have already learned, here are some function operations that will be helpful to know and memorize. For addition operations, f plus g of x equals f of x plus g of x. For subtraction operations, f minus g of x equals f of x minus g of x. For multiplication operations, f times g of x equals f of x times g of x. For division operations, f over g of x equals f over x over g of x. When performing operations on two functions, substitute the values given for f of x and g of x and solve. The inverse of a function replaces x values with y values and y values with x values. When graphed, the inverse of a function is reflected across the line y equals x. Using the horizontal line test, you can test the graph of the inverse of the function. If a horizontal line can be placed on the graph anywhere without intersecting the graph more than once, then it is a function. If it intercepts the graph more than once, it is not a function. Thank you for watching, and we hope you enjoyed this tutorial.